Hi. Um, so first and foremost, apologies for starting a little bit late. It seems I've lost track of an entire hour. Um, so if you can't make it to this lecture live, completely understandable. That's on me. We still want to give you space to ask questions though. So I will still be pausing for questions in the middle of this. The idea is if you choose to rewatch this broadcast, and if you have any questions during those pauses, please, I encourage you, reach out within the Slack channel, like directly at me. That's totally fine. I'll probably end up making a thread for any questions as well. So you can ask there and maybe interact with anybody else who has any questions, just so we can still have that space to interact. So yeah, in the rebroadcast, if you have any questions, please, I'll be making a thread to for anybody who is watching after to ask questions. Okay, great. So with that, I can hear myself through Twitch, and I'm going to turn that down. Okay, great. Now we can get started. What are we doing today? Good question. It seems like we're talking about introduction to data visualization and graphs with Matplotlib. So, right. First, let's do a bit of a recap. What did we talk about? What have we talked about already? Last time we talked about Pandas, an incredibly powerful tool within Python to manage large amounts of data, essentially being able to organize our information into data frames, which are table-like structures with columns and rows. So we talked about how to load data into a data frame. We talked about how to clean it up so it's easier for us to use down the line. We talked about indexing data frames, so we could take specific rows from the data frame and just look at those pieces of data. And we also talked about aggregate functions to look at information that applies to certain swatches of the data. Good. These are all important skills to have. But today we want to be visualizing. What is visualization? Why are we doing it? Well, visualization is pretty intuitive. It's kind of in the name. It's representing data in a graphical format, right? Here we have a data frame, just as we did last time. If you go into Pandas and just type in df or whatever the name of your data frame is, you get something like this. And this is nice in theory, I guess, if you're a robot. But if you're a human being looking at this, first and foremost, we have like not every row, because if we did have every row, that would be completely overwhelming. But even if we did see every single row, us as humans would not be able to take a whole lot of information from it, because every single piece of information that we have is super granular and doesn't tell us a whole lot about the entire picture. So in order to actually get the entire picture, we create the picture visualization, right? We've turned this not really human readable format of presenting information, and we're going to turn it into, a graph or a chart or something that we can actually look at and be able to take some information away from, right? What does it help us to do? It helps us explore data. This is a little difficult to parse, and even if you were able to parse it, you probably wouldn't be able to take too much away from it, even from like a good bit of line by line study on your part. But if you look at this graph, it's a lot easier to explore what's going on, right? Just in this alone, we can tell that there are trends. We can tell that there are directions that each whatever is heading in, so on and so forth. Okay. And secondly, it helps us communicate ideas. This does not communicate really any idea to any people. It doesn't communicate ideas to like data scientists, and it certainly doesn't communicate ideas to like the everyday person looking at this. This, however, this communicates a story. This tells us, well, there was an upward trend in MSFT, and then there's like whatever. This is stock market stuff. So if you're showing this to investors, this actually means something. If you show this to investors, they'll probably kick you out of the boardroom. Great. So that's what visualization is, and why visualize, right? Without it, data is less meaningful. Like, this doesn't mean a whole lot to us. It's messy because every single tiny little bit looks the same. So any stuff that's like outlying or anything that's perhaps not representative is going to matter to us just as much as everything that is, unless we're like somehow robotically able to parse that it's like not part of the central. It's messy. It's hard to understand. For humans, looking at this is not intuitive. With visualization, we can see patterns, right? We see trends. We see what's really going on. and we're able to extract some meaningful analysis out of it, right? The whole point of data science is that we get this, and we're able to extract and analyze information out of it. And without visualization, it's a little difficult to do. With visualization, it gives us a pretty clear and concise way of doing that, especially to people who don't like study hard data science, statistics, whatever. Right? This means something. This doesn't mean a whole lot. I mean, it does, just not to the human eye. That's why. Yeah, so recap, this is difficult to make sense of. Yeah, this is easier to make sense of. That's the quick version of it. So what are we going to be studying today? We're going to be using more Python packages. We're going to be using Matplotlib. So Matplotlib is an incredibly expansive package within Python that handles a lot of things regarding visualization, not just with data, but just in general. But we're going to be looking specifically at the library part of the package called pyplot, which is the package that we are able to put information into, and then it will spit us out meaningful graphs and charts with that data. And more specifically, we're going to be using the plot command. Right, the plot command ends up coming off of the plot ends up being a method that comes off of the data frame from Pandas, because Matplotlib and Pandas work incredibly close together. So we're going to be using a lot of pyplot.plot in order, and we're going to be talking about the different parameters that we could pass into it in order to get different kinds of charts. Right. So we're going to be talking about figures and subplots, so more information on how we can get more refined details and have stricter control of exactly what we're plotting. And we're going to be talking about different graphs, relational graphs, bar plots, histograms, line plots, scatter plots, really fun. And then in the end, we're going to take a look at a more maybe creative application of this, and we're going to map longitude and latitude from a set of data. That'll make more sense when we get there. Okay, so that's what we're going to be doing today. Let's get started. First and foremost, what is the data set that we're going to be looking at? It's difficult to do data science or demonstrate data science with that data. So here it is. We're going to be taking a look at a stock market index data set. Yes. So this is pretty clear. We have a bunch of pretty big companies, and we're going to be tracking how much their stocks cost from 1990 daily up until pretty recently. And we've got some big companies here. You can read this. And we're also looking at some, the fact that I don't study finance is really showing here. I'm pretty sure S&P 500 aggregates a bunch of big companies, 500 of the top companies. So that's that. Aside from that, big companies, big names over here. Hopefully we'll see some information that ends up being kind of interesting, along with a demonstration of visualization. Okay. And we're also going to be looking at a California housing data set later on for the longitude-latitude sort of demonstration. This is information collected from the 1990 California census regarding information about houses in a California district. And in that data set, we have certain information about each household, like the house's longitude, the house's latitude, so on and so forth. The ones that we're really going to be looking at are housing median age and population. So already we can sort of tell we do have this information in here, but just looking at the data set as a whole, it's kind of like not super meaningful. Okay, pausing for questions about concepts and what we're going to be studying. Okay, plotting with Pandas and Matplotlib. So again, what is Matplotlib? It's a data visualization library, right? And it works really closely with Pandas, right? That's the sort of nice thing about data science with Python. All the big packages work really well together because like either they're built on top of each other or they know that each other exists and they were designed with the others in mind. So Matplotlib, Pandas, we'll be looking at other packages like Seaborn and NumPy. They all work really closely together, which means that things that apply within each package will carry over between packages. And that's really nice. And we're going to be looking specifically at the pyplot subpackage of Matplotlib, right? PyPlot focuses mainly on plotting, while Matplotlib will focus on a broader range of visualizations. And it's designed, fun fact, it's designed to be a little bit like MATLAB, which is a computational mathematics program that's designed outside of Python, and is, in my opinion, and I believe in the opinions of the people who made Matplotlib, kind of a pain to use. So, we're replicating it within the Python environment. And there are other things, other subpackages in Matplotlib for things that aren't plotting, but the one we're looking at today is matplotlib.pyplot. So let's talk a little bit more about the relationship between Matplotlib and Pandas. Pandas has a method for the data frame object called .plot, and it implicitly uses Matplotlib. Like behind the code, like in the Pandas, documentation, it's actually calling Matplotlib. But the nice thing is when we use it, we don't have to call Matplotlib. And that makes it really easy for us because we can go through Pandas to get to Matplotlib. See, now this is really nice because it ends up being a simpler method and the implementation is easier. But it also means that we lose some of the precision that comes when that we would get if we plotted directly through Matplotlib. So in order to reach a sort of balance, today, every time that I show you how to use something with df.plot, I'm also going to be showing you how to use how to get to it through Matplotlib. Because having the precision is nice, but also having the simplicity is nice. So let's do both. Okay. And right, now we're getting into the code. So as with last time, we are going to be importing the libraries first. Because if we don't import the libraries, then Python doesn't know that we want to use them in the first place. So we're importing pandas as PD. Again, it doesn't really matter what you import it as, but PD is kind of like the standard name. So every time we want to refer to pandas, we're actually going to be calling it PD. And we're going to be importing Matplotlib, but the specific subpackage, pyplot, and we're going to be calling it PLT. Again, like pandas, you can call it whatever you want, but PLT is kind of the thing that everyone's expected. And then we're going to be importing datetime. More on that later. Datetime is basically a package that allows us to manage dates and times in a more powerful fashion. But more on that later. Okay, and then like last time, we're going to be loading the CSV. Right, we have the entire link that we've linked in the practice in the collab, and then we use pd.read CSV, and then all this sort of thing. What is parse dates? Basically, if the reader runs across something that looks like a date in the CSV, then it's going to be converting it to a date time object. Date time, same date time as here. The date time object has a little bit more functionality than just like the raw string that contains a date. And so it's nice to have. And then the next one is there. Sorry, I have it pulled up here. Oh, right, I have to import it. Right. Okay, here it is. So this is directly where I grabbed the thing from the beginning, where I said that it's not really clear what it is. So let's try to visualize this data. Okay. So this is what you get. Kind of a hot mess. Okay. Now we're going to be calling df.plot. Now this is a big important function, and we're going to be spending a lot of the class today looking at it. So if we just call df.plot raw from it, we end up getting this thing. So not great. It's kind of difficult to tell what's going on here, particularly because there's like a lot of things clustering down here. There's like a giant gray line going on up here. Why might this be the case? Well, these are each specific company. Looks like Apple is doing particularly well in 2012. But this gray line is the S&P 500. If we go back, right, S&P 500, as I mentioned, it's an aggregate index of how the top 500 companies are doing. So naturally, it's going to be a little bit bigger than each individual company, but we're plotting it on the same scale. So yikes. It means that this is just going to way overshadow everything that's down here and make it difficult to see. Right. So tough. But already, even though it's not super useful, it's a little bit more useful than this in that at the very least, we can sort of tell what sort of trends are going on in the S&P 500. Right? We have 2001, it's rising until 2001, and then it crashes, the dot-com bubble, whatever, comes back up, crashes during the Great Recession, and then slowly comes up during 2012 again. So we already see a bit of a narrative starting around here, but we can do better if we wanted to get more specific looks at the information. What if we want to plot a specific column, right? So what if we only want to plot the values from the AA column? Oh, I should mention, when we call df.plot, it takes the x-axis is going to be the index, right? And they recognize that the x-axis, their dates, so it just gives us the dates going forward. That's nice. And then the y-axis is going to be whatever values are in the body of the table. Right. So what if we only wanted to look at the information? Oh, right. Each column is a different line, right? And each column is represented in this legend. Great. The df.plot, if you don't pass anything into it, it's just going to make these assumptions for you. So we want to have a little bit more control over the assumptions that it makes, and that's why we're going to be studying this. So let's say that you only wanted to plot information from the column AA. AA here corresponds to American Airlines, right? What if we're just really curious about how American Airlines is doing? And we don't actually care about the rest of this? Well, what we do is that we pass a parameter y is equal to AA, right? Basically, we're saying, okay, we want to plot this data frame, but we only want to be looking at the column labeled AA. AA has to be the same string as it is in the column. So what happens when we do that? Oh, right. So this is how you do it with pandas, with df.plot. This is how you do it with matplotlib. Basically, what you do is you call plt.plot, right? And you want to index the data frame at the column AA. This is to say that we only want to be looking at the pieces of information from the data frame that are in the column AA. And then plt.legend specifies what the legend is going to be. You see that we have a legend here automatically generated by df.plot. For Matplotlib, we need to explicitly specify that the one line that we have in there is going to correspond to the to AA in the legend. And then plt.show, we need to explicitly say that we want to see the plot. And there it is. Now we only have American Airline. And again, Matplotlib/Pandas have made the assumption for us on what we want to be doing with the scale. They assume that we want to kind of be filling up the entire frame with the y-axis. But you'll note that it starts at 5, so that's something to keep an eye out for the visualization. But now we're looking at American Airlines, and this is pretty good, right? See that in 1992, pretty small company, grows, fluctuates a little bit, gets pretty big in 2008, and then whoops, Great Recession, and it's back to like whatever in terms of stock prices. You'll and recall that x-axis is still the index, even though that we've changed which columns that we're looking at. In fact, we're looking specifically at the one column. The x-axis is still the index. The index has not changed. The x-axis has not changed since we just called df.plot in general. That's nice. Okay. What if we wanted to have a different x-axis though? Let's say we don't actually care about the date. We want to be plotting, the relationship between GE stock prices and American Airlines stock prices for whatever reason. Well, if you want to reset the x-axis, all you need to do is you call x equals and then the column name of the x-axis that you want it to be. So let's keep in mind, right, what would this actually be plotting? This is going to plot on the x-axis, it's going to plot GE, so 2.87. And on the y-axis, it's going to plot AA. So 2.87, 4.98 is going to be plotted. And then 2.87, 5.04 is going to be plotted, and it's going to try to connect that. 2.87 is going to be plotted against 5.07. And so it's not really going in chronological order now. Every time that GE moves, it's going to try to connect it. The x-axis is going to plot GE, and then it's going to correspond to the y-axis point, AA. 2.87, 5.07. 2.88, 5.01. Yeah, so if you imagine like a Cartesian coordinate plane, you're just plotting points like that. So, imagine, unsurprisingly, it's kind of a hot mess. So why is it a hot mess? Because, first of all, we're plotting two stock prices against each other, and we're trying to connect the points every single combination of points that happens. This isn't really meaningful information. I mean, unless you are studying something about the relationships between GE and American Airlines at any given point. But even then, this is not a good way to do it. Right. Because first and foremost, you'll notice the index for this grows, pretty continuously, right? Day 1, day 2, day 5, day 6, day 7. I don't know what happened day 3 and day 4, but it kind of grows continuously, right? It's not like hopping back and forth. But GE, it does hop back and forth, and pretty randomly, actually. I mean, there are trends, but more or less pretty randomly. And the column for AA is trying to keep up, and it's still trying to connect everything together. So when it tries to do that, you end up getting a kind of a random scribble. So this looks terrible because we want to be plotting continuous variables for the x-axis. This is just a guideline. Again, if this is actually what you want to be looking at, then more power to you. But to most people, this doesn't mean a whole lot. Right. So this feels like a good time to pause for questions. Okay. So yeah, ask anything in the Slack. I will start a thread immediately after this presentation. Cool. Okay. So here's a better way to do it. If you do actually want to plot the relationship between, two companies, maybe don't plot them from X to Y, because that's going to try to directly associate each individual price point of the GE stock at any given time to the price point of the American Airlines stock at any given point. What you might want to end up doing is you might want to plot two columns concurrently, right? So what does this mean? So before, if we just wanted to plot American Airlines, we called y is equal to AA. And we only got this one column. We got the AA column. Now we want to be plotting two columns at once. So what you might want to do, or not might want to do, what you have to do is that you want to be putting the different names of the columns into a list and say y is equal to that list. So in this case, we want to be plotting the columns for American Airlines and Microsoft. So we put American Airlines and Microsoft, or at least their column headers, into a list and saying y is equal to that. And when we do this, then we get this nice two lines in this line plot. And now using Matplotlib, again, it's kind of the same deal. You just have to call plt.plot again, this time with a different column of the data frame. So this plots specifically the Microsoft column. Great. And notice that in the legend, we have to be specifying that the first line is associated with the legend AA, and the second line, the second plot, is associated with MSFT. And we'll show the plot again. Here we go. This is kind of nice. This tells a story. Generally, when, up until 2000, Microsoft is doing pretty well. It even surpasses American Airlines at some point, because I guess people decide that they need computers more than they need airplanes, which at least now is true, which you'll look here kind of happens modern. Anyway, and then it crashes because .com bubble, and Microsoft is a big tech company, so naturally. And then, 2008, everyone kind of eats it, but Microsoft a little bit less, it seems. Learning something. Hope you're learning something here, too. That's the power of visualization, right? We wouldn't be able to learn that through the data frame, but we're learning it here. Okay, anyway, that's how you programmatically get two plots into the same graph. So, great. Now we're going to be looking at different customization options for the graphs. So what if we want to be labeling the x and y axis? This is always a good practice. Otherwise, it might not be super clear what you're talking about. Well, then you just pass in the x label parameter and the y label parameter into df.plot. Excuse me. So syntactically, we call what this looks like the .plot method. We call it just by saying df, the name of the data frame that we're going to be calling it from, .plot, open parentheses, and then within the set of parentheses, we pass in our parameters. we passed in y is equal to, and then our list of column names that we want to be looking at. And then that's one parameter, and then comma. And then the name of the next parameter is equal to whatever, comma. Yeah. This should kind of remind you of key value pairs in dictionaries, where we are associating a value with some key, except people have already defined these keys, and they're the names of the parameters. Anyway, that's drawing comparisons. Anyway, so if we want to be, if we want to label the x-axis or the y-axis, what we do is that we pass the names that we want to be we pass in the labels to the x-axis and y, good lord, the x label and the y label parameters. Right. Yeah, this is pretty clear, I think. With Matplotlib, kind of the same idea. The thing with Matplotlib is that when you call plt.plot, it just like keeps track of every single thing that you do and assumes that you're going to be putting it on the same plot. So when you call plt.plot this first one, it's like, okay, great, I'm going to be plotting this. When you call it again, they don't think that it's another one. They're just going to put it right on top of the first one. And then the x label, they still think you're talking about the same graph. And so that's nice. So all we do is plt.x label and then the name of the x-axis label. And then same with y label. It doesn't really matter what order you put x label or y label in here. The important thing here is that you need to put legend after plt.plot. So generally, good practice, get plt.plot out of the way first, because that's like the meat and potatoes of your graph. And then the rest of them. And then plt.show last, because, yeah. So here's a result. I've boxed what changes that we have from the previous one. All we've done is that we've added the x and y labels. Okay, so now we have now you try segment. And by now you try, I mean, we'll try. I mean, pause this and try yourself. But, you know, if you want to join me, I welcome it. Okay, so here is stuff that we've been doing. Great. We've talked about this, plotting multiple columns, adding labels. Yes. Okay, now try this. Plot 2 columns of your choice, a Microsoft on the same graph. Okay. So df.plot, that's what we've been doing this whole time. And in order to plot some columns, recall that we need to be passing y is equal to. And then y is equal to what? Okay, if we want to plot more than one column, then we have to have a list of column names. And let's choose which columns to be plotting. I choose, what do I care about? Pepsi and Johnson & Johnson. Actually, you know what? I'm going to do Apple and Qualcomm, because that, is that Qualcomm? I'm curious. XOM. No, it's ExxonMobil. Okay, never mind. Sure, ExxonMobil and Pepsi. Maybe we're drinking oil. Who knows? So the Pepsi column is PEP, and the ExxonMobil is XOM. So we're passing in the names of the columns in a list of the names of the columns that we're going to be looking at into y is equal to. Right, and now we are going to have to pass the y label. And the y label is the string that we want to be associating with the y-axis. And so what are we actually plotting along the y-axis? What does the y-axis represent? That's the stock price. And what is the x label? Well, what are we plotting the stock market price against? We're plotting against the year. What are the years? It's like 1980, maybe. Yeah, 1990 to 2011. 2011. Great. So what do we get? Wow, look at that. ExxonMobil did really well during the presidency of George W. Bush. You know, make of that as you will. But yeah. So that's the deal. If we want to be doing this with Matplotlib instead for any reason, generally you want to be following this up here, plt.plot. Plot, and then the name of the, and then we index the particular column. And then we do it again, except for the other column. And then we add some x labels, plt.x label, stock market price. then plt.ly label is year. And then legend. And then a list of the legend values. In fact, we'll even say that it's Pepsi and that it's Exxon Mobil. Right? Mobile. The nice thing about Matplotlib is, again, we have a little bit more control. Here in the legend, we can actually name it rather than just letting it assume that we want it to be the same name as the columns. So here it is, same graph. Legend does a little more specific. Great. Hope you guys were able to get that. If not, again, drop a question in the chat. Please at me. I'll do my best to answer. So we have now tried. Okay, let's keep moving on. Now, instead of adding an X label or a Y label, let's try to add a title. Kind of the same deal, just pass in one more parameter to df.plot. Title. This one's pretty intuitive. Same deal for Matplotlib. Everything's the same as before. Now we just have a line that's just the title. Stock market index for American Airlines and Microsoft. Excuse me. Now we know what we're looking at, so that's good. Okay, and now what is alpha? So alpha is referring to the transparency of the of what we're plotting. So if you look here, right, this can be kind of rough because the lines are overlapping, and so like here it's difficult to see what's going on in the blue line. If we don't want to deal with that, we can make the line a little bit more transparent. And the way that we do that is just that we pass in a parameter alpha. Alpha should be a number that goes from 0 to 1. The closer to 1 it is, the less transparent it is. The closer to 0 it is, the more transparent it is. 0 is fully transparent. Don't set it to 0. Or do, but you wouldn't see anything. Right, the way that we have to do it with Matplotlib is that you'll notice for df.plot, everyone gets the same alpha value. For Matplotlib, we can pass in individual alpha values for different plots. So if we were to do this, then this means that the alpha value for the American Airlines column, the American Airlines line, is going to be 0.8, and the same for Microsoft. We could change that. We can make it different if we want to. So here it is. If you zoom in a little bit, 0.8 is kind of not super dramatic, so maybe I'll send it to 0.5. Down here, yeah, see, it's a little more transparent. Yeah, that's how it works. All right. Again, like I said, don't set it to 0 because you're not going to be able to see anything. Yikes. But anything in between, the more lines that you have going on in the same place, the more it would make sense that you don't want them to like overgrad. This is a matter of aesthetics, and you should have an eye for this. Keep in mind, even though this is aesthetics, we are studying it in a data science class because visualization is the way that people take in information. So having people be able to understand the data visualizations that you make in terms of an aesthetic quality is important. So keep an eye out. Think, would people be able to make sense of this? If the answer is no, then you might have to take another pass at it. Okay. And now you'll notice, okay, maybe these are a little bit small. Yeah. So let's say we wanted to make it like a little bit bigger. I guess it doesn't work so well in presentation format, but like if we're looking at it here, this is pretty small. What if we want to blow it up? You'll notice that like the resolution on these is kind of crummy because they are so small. So we want to make it a little bit better, right? We want to be able to blow it up, all that. The way that we do that is that we pass in a fig size tuple. So recall what a tuple is. It's another way of storing bits of information, except tuples are immutable while lists are mutable. Imagine it like an XY coordinate, where the X coordinate is going to be the horizontal width of your graph, and the Y coordinate is going to be the vertical height of your graph. So 10, 7 means that it's going to be 10 units left and right, and 7 units tall. Matplotlib automatically generates these for you based on assumptions about how big you want it, but this is nice if you want to set it yourself. So the way that you do it with Matplotlib is that you need to create a fig object first, right? So you say figure is equal to, and then you call plt.figure. And plt.figure lets you set a bunch of parameters for the figure. The figure is to say like the kind of the canvas on which you're putting your plot. So plt.figure gives you a lot of options for parameters that you could pass into it to change, different aspects of your canvas. But this one, again, it's just fig size again. Again, it's you pass in a tuple with the width and the height that you want it to be. And again, old plot, small, new plot, bigger. That's pretty intuitive. Okay, pausing here for questions. Okay. Now, let's say you want to get a little bit fancy with a graph, right? Right now, it's been a lot of like orange lines and blue lines. They've been making the choice for us, which is kind of nice, but like also what if we want it to be different? So these are optional, but there are two ways to do it in df.plot anyhow. First, we can like crunch it all together. df.plot gives us, x is equal to, y is equal to. If we were to keep everything in their positions, then in the third position, we could pass in a style argument. Right, and the style argument breaks down into this. First, we have the color, then we have the marker, and then we have the line style. Color is pretty intuitive. For a line, depending on what we set the color is equal to, it changes color. Marker is going to be how we delineate each point of data, and line style is going to talk about like different ways that we, connect the lines, connect the points. So here's a large list of what's going on. These are the list of different available colors. This is a list of line styles, right? Based on, depending on how you want to pass it in, we're going to get a different way to connect the lines. And then here's different ways to mark the points, right? Yeah. So passing it all in through one style argument is fine, but it's equivalent as passing in parameters with the names. So color is equal to R, marker is equal to O, line style is equal to that, dash is the same as passing in RO dash. Personally, I like to split it up because I think it's way more intuitive. And also you don't have to worry about positioning, what order your arguments are going into, what order your parameters are in. But yeah. And also, if you have multiple columns, you have to make sure to use the style argument, right? Because this is going to associate, if you pass in a series of style arguments, then we associate the first line, the first column that we're plotting, with the first style argument, and the second with the second, so on and so forth. So in this case, we're going to say that the AA, the American Airlines line, is going to be red. The markers are going to be circles. It's going to be connected by a line. And the Microsoft line, the Microsoft graph is going to be blue. The marks are going to be X's, and it's going to be connected by dotted lines. Yeah, and then with Matplotlib, it's sort of the same, except instead of getting its very own line, it goes right into the plt.plot argument. So just put it directly after the first argument, the style, just put the style argument there. And then this is what it looks like. Yeah, so once again, you want to be making your choices pretty intentionally on why you want to make certain styles what they are, because sometimes it can be a bit of an eyesore. I'd say that this is a bit of an eyesore, hard to look at. But, this gives you the power to do so. Right, now you try, right? Styles can be a little bit funky, so it's probably good to work through one. Right, set the figure size to 10.7. Plot the column. Whoops. Don't look. That's the answer. Okay, so I want it to look like this in the end. So what do we want to do? Okay, well, we're going to start with the f.plot. What is the y-axis? What is the y-axis? What is the column that we're plotting? We're plotting SPX. S&P 500. Okay. So let's just do this. Ready? Fig size, right? We just passed in fig size parameters, 10.7. Pass it in the tuple. What else? Add the X label and Y label, sure thing. X label is equal to what I set it for stock market price. Don't forget the comma. Y label is equal to. I just mixed up X and Y. That's embarrassing. Y label. X label is 8 from 1990 to 2012. Yeah, and then title index for SPX. Right. And now we want to be talking about the style. So style, let's come up with a style argument. So it's going to be a string, and we want it to be a dash line and orange. So color first. Orange. Orange is okay. This is why it's nice to do it explicitly. All right, let's call color first. Let's do color and then line style and color. Oh my lord. Okay, color, marker, then line style. So we want the color to be orange. Most of the time, if you just type in the name of a basic color into the color parameter, it'll just give it to you. It's kind of nice like that. And also, to be fair, we don't have a specified marker. So this is probably a more explicit way to do it. And then we call the line style. And what is the line style? That is associated with the dash line. Let's go up here. Dash line is that. Yeah, and there it is. We have dash lines between each of the points within the SPX. Just to make sure that we're actually getting between the points, let's say a marker is equal to X. We can say axis. Yep, that's hard to look at. Boy, howdy, is that hard to look at. Can we get something a little smaller? Dots, pixel marker? Sure. Okay, I guess that's kind of what it was before. That's the idea. Okay. Cool. Again, if there are any questions, do ask. Okay. So what if like we don't actually want to be looking at all this information? What if we only want to look at the dates from like 2000 onwards? Sure. Then we need to be limiting what the x-axis is, what the x-axis can be. So we have something for that. It's called xlim. And let's look through an example first. This is just going to be like a sample data frame. What does it look like? This is this, right? What have I done? Yeah, this is just a test data frame. The point is, it ends up plotting to be like a parabola curving upwards, and we're going from 0 to 8. Right. But what if I don't want it to go from 0 to 8? I want it to go from 2 to 6. Then in the plot, we specify xlim is equal to, and it's a tuple that starts, whose first value is the start value, and the second value is the end value. So I only want it to go from 2 to 6, so I pass in xlim is equal to tuple 2, 6, and now it only shows us the values from 2 to 6. That's pretty simple. Okay. The reason I want to show you this simpler example is because our example is going to be kind of difficult. And I'm going to ask you to bear with me here. And if you do have any questions, again, please ask. This is where the date time thing comes in. Because, right, if you remember in our read CSV, we asked it to parse the dates, right? Which means that it converts all the things that look like dates into date time objects. So if we just pass in numbers to xlim, it's not going to recognize it because the index and therefore the x-axis, they're all just going to be numbers. If we try to pass in numbers, it won't recognize it because the x-axis isn't actually numbers, they're date times. They're date time objects. So in order to actually get the appropriate start and end for the xlim, we also need to be passing in datetime objects. And how do we make a datetime object? Well, with the datetime package, what we do is we call datetime, name of the package, .date, and then we pass in the year, the month, and the day. Right, so in this case, we're making a datetime object that is associated with the year 2000, 2006 and January 1st, 2006. Right, so that's the start. That's the first day that we want to look at. So if we go back here, this means that our start is going to be around here, and our end is going to be 2010. Okay, same deal. With Matplotlib, it's another function that you're calling from the PLT subpackage. It's just xlem, and you'll note that this time the argument is not a tuple, but it's actually two different objects, right? So don't pass a tuple into xlim, just pass in the start and then pass in the end. It's a little bit different. But you'll see here, this is what we get instead. So before, we had everything from 1990 to 2012. Now we're only going from 2006 to 2010. And the nice thing about the datetime object is that when it gets, when you zoom in, instead of like trying to treat them like actual numbers, it treats them like dates, right? So January, July, instead of just like 2008.5. That doesn't mean anything. Okay. Hopefully that makes some sense. Right, and now we'll try it, because this is a little bit weird, combining the datetime with the xlim. Okay, plot SPS index from 1998 to 2002. Let's do that. Okay, so once again, df.plot. We're plotting the SPX index. So it's still y is equal to SPX. And we want to set the index from 1998 to 2002. So we want to be passing in the tuple, that's the start, and then the end. What is the start? Well, it's going to be the date time. It's going to be the date. And what's the date? The year is 1998. And let's say we're going to look from July 1st, January 1st. And what's the end? It's the date. So we need to make the datetime object again. That's in 2002. And here we are. I haven't passed in any of the other parameters. Let's just copy and paste them over. Okay. And there you are. We are only looking at the values from 1998 to 2002. Yeah. If we don't consider the date time, it's even a little bit easier. If we want to be looking at this, right? This is the entire plot. But now if we want to limit what the x-axis is, we pass in the beginning. Let's say only want to go from 1 to 9. Right. Tuple 1, 9. Great. Okay. So there that is. Let's let's also do this with Matplotlib. So we're doing plt.plot still, and what we're doing, we're calling df.spx. Right. What other things do we want to show? Right. Xlim. plt.xlim is equal to, and then we want to pass in the start. The start is still our date time from 1998 to date time, not date, it's 2002. And recall, notice here that we're not actually passing in the tuple, we're just passing in two different values. There we go. Oh, yeah. Technically, you don't need to do plt.show when you're working on Colab, because the nice thing about Colab is that it just assumes that you want to see things. But, you know, good practice, plt.show. Yeah. I put the semicolons here because you'll notice, like, if I don't put the semicolons here, and if I don't have plt.show, you know, Colab makes the assumption that we really, really want to see everything, which includes this, which you don't really want to see. So the way that you get rid of the excess stuff and say that you don't want to see it is you add the semicolon there. Yeah. That's specifically for Matplotlib, though. That's kind of not something that you'll see in Python in general. So that's it's a convention borrowed from MATLAB. So if you recall from what I said earlier, Matplotlib is based off of MATLAB. So yeah, borrowed that from it. But that's the gist. Okay, let's move on. So we've been looking at line graphs this entire time. But I'd like to think that there are other kind of graphs, and there are. Like, look at all these guys. So how do you plot a different kind of graph? The way that you do it is that you use the kind parameter in bf.plot. So you'll notice right here, bf.plot, and then you pass in kind is equal to, and then some string. And whatever string that you pass in is associated with the type of plot that you're making. So this is non-trivial, right? It just sort of assumes that you're making a line plot, but you have to make the active decision to do something other than that. And when you make that active decision, you better be making it for a good reason, right? Like, don't like, why are you going to pick a bar graph over a histogram over whatever, right? Why would you choose an area plot over a, actually area plot's kind of specific. Yeah, why would you choose a bar over a histogram? Why would you choose a line over density over scatter? Make these decisions with intent, right? The key to good visualization is knowing why you're doing each individual thing. Good. So what is a histogram? Histogram is it plots the counts of values in columns, and it shows off the value frequency, right? So let's say we have a list of numbers 1, 2, 2, 3, 4, 4, 1, 4. Right. This is our data. A histogram will tell us how many times does each number occur. Yeah. So if we want to plot how many times each number will occur, then that's when we use a histogram. And it counts within a bin or a range. What I mean by this. So it's really convenient here that the numbers are super specific. Like, we only have 4 values, but let's say it gets super granular, like 1.1, 1.01, 1.111. And then if we just like plot each instance of that, especially if it's a continuous variable, right? If it gets super granular about each individual value, then like we're just going to end up plotting very few, like one of each, right? Like if our data was more like, our data ended up looking more, we don't have the example here. Yeah, if our data looked like 1.1, 1.001, 1.2, 1.13, 1.111, right? Like all these values are pretty close to each other, but they're not exactly to each other. So it would be kind of impractical to count the exact frequency of each value. So what the bin does then is that it will create like compartments for the counts to happen. So let's say we have a bin that counts from 1 to 2, and we have a bin that counts from 3 to 4. So every time we have either 1 or 2, the frequency for the first bin will tick up. So there's 1, 1, so 1, 2 will tick. The bin for 1, 2 will tick up. Imagine like you have the data, and the data is like stuff that you're throwing into compartments, and there's a compartment labeled 1, 2, and there's a compartment labeled 3, 4. Every time we have a 1 or a 2, or anything between 1 and 2, we throw it into the 1, 2 compartment. Anytime we have a 3 or 4, we throw it into a 3 or 4 compartment. That way, instead of like granularly counting, we have 2 1s, we have 2 2s, we have 1 3, and we have 2 4s. Now we say we have 4 values within the range 1 and 2, and 3 values within the range 3 and 4. This is incredibly useful for when you're looking at continuous granular data. Okay, so now we're going to be looking at a histogram. With respect to the fact that this is a stock market, it's a little less practical, but this is for demonstration purposes. Think about why you're using each graph. We're using histogram here because it is a demonstration. So yeah, once again, we are passing in kind is equal to histogram. And since this is a histogram, we need to specify how many bins there are. So we pass in the bins parameter. We'll say that there are 30 bins. The way that this works is that it'll look at the top value, and it'll look at the bottom value, and then it'll equally divide it into 30 bins. Yeah. So like here, I said 1, 2, and 3, 4 are each bins. That would be the same as saying that there are 2 bins. And then I've equally divided the range into 2 bins, 1, 2, and 3, 4, from 1 to 2, and then from 3 to 4. So we're looking at the top values and the bottom values, and we split it equally into 30 compartments. And once again, we're looking at the columns IBM. Well, not once again. We're looking at the columns IBM and American Airlines. Matplotlib is a little bit different. We don't just get to pass in kind for free. We need to specify, instead of using plt.plot, we're using plt.hist. Otherwise, it's pretty much the same. We pass in bins to each call of hist. And then we get this. So what does this actually tell us? So if we look back to what Microsoft and AA look like, if we look back to what Microsoft and AA actually look like in our plot, I'll do that with bf.plot is equal to y is equal to IBM AA. Right. Really? Okay. Okay. So if we look at it here, the values for Apple, they tend to cluster like pretty low. They tend to cluster from here, and then there's like fewer values above 25. So you'll expect in the histogram that Apple will see that most of the values are clustered kind of low, which means that the frequency for lower values are toward the lower end, so left-hand side, and the frequency for the higher values are going to be not as much. So it's going to be a little bit lower on the right-hand side. And that's exactly what we have here, right? Low company values, low stock prices are more frequent. So we'll see that the left-hand side is pretty high, and then they taper off. And then for IBM, we see that there exist values. So the frequency for higher values is going to be higher than Apple's, and they also tend to cluster around this like middle range. They spend a lot of time in this mid range. So you'll see that the frequency of middle values for IBM are going to be a lot higher than for that of Apple's. And lo and behold, that is what you see. Okay. So hopefully that makes some sense. That's the idea of histograms. So now we're doing an area plot. Yeah, we're plotting the area underneath the curves for each of the different columns. So kind of equal to area. Yeah, that's pretty much the only change here. So there that is. Yep. In some instances, you will want to have this over a line plot. So once again, consider why you're doing each kind of plot. And then bar charts. Bar charts are a little bit different. We actually had to come up with a different example for this because bar charts plot the quantities across categorical data. Right? Histograms are different because we're counting like different values, like frequencies of different numerical values and ranges. But in bar charts, we're actually counting like we're associating values and frequencies to like categorical data. This categorical data is not numeric, right? Annie Hall is not like the number 1, right? We're saying that the number of Oscars, 5, some value, is associated with the category Annie Hall, and 11 with Ben-Hur, and so on and so forth. Right? This is different from a histogram, where like the easiest way to tell is by looking at the x-axis. If the x-axis is like some sort of continuous, is a continuous variable, is a continuous numerical variable, then it's probably a histogram. If the x-axis is like categories or names even, then it's probably a bar chart. They're for two different things, so be careful of that, right? It's easier to mix up bar charts and histograms because they look so similar to each other, but there is a difference. Right. So we're actually going to be looking at this data frame for the bar plot. So df for bar plot, we're no longer looking at the stock market. So kind is equal to bar, fair enough. X is equal to movies, right? Movies is the name of the movies. So the x-axis is the name of the movies. Makes sense. The y-axis is the column number of Oscars, right? We're plotting the number of Oscars against the name of the movie. Title, X label, Y label. Sure. This gives you that. Right. Now you try. Yeah, let's try. Okay. Okay, let's do the histogram first. Okay, plot the histogram for A, PL, and G together. So we're doing df.plot because we're looking at our stock market data. And what is our kind? We're plotting a histogram, so it's hist, right? What columns are we looking at? We're looking at A, PL, and we're looking at G. And the labels. What are the labels? What are the labels? Okay, so Y label. This is going to be the frequency of stock price, and this time the X label is going to be the stock price. Right? Let's look at this example up here. Right? The stock prices are listed down here, and we're asking how many times does the stock price or an instance of the stock price occur. So the frequency is the Y, and the actual stock price is the X. Right. And then set bins is 30. See what happens. Let's make the figure size a little bigger. Okay. What do I notice? We'll see that like both Apple and GE have spent most of their times clustered at lower ends of their of stock prices. Right? Let's see, does this make sense if we just look at the plot? Yeah, it does, right? Apple have spent like a lot of time being a not very pricey company, and then spent a little bit of time being a very pricey company. GE, on the other hand, has spent a lot of time being a not very pricey company, and has spent no time being a very pricey company. And the histogram that plots the frequencies reflects this. Right? GE has spent a lot of time being a not very pricey company and no time being a very pricey company. Apple has spent a lot of time being a not very pricey company and a little bit of time being a very pricey company. So that's how to parse a histogram. As for the bar plots, okay. So here we have, check the two lists are equal. Yikes. Convert the two to data frames and call it cal state and roll. Okay. All right. Fair enough. So let's check if they're equal. We're saying that they're equal if their lengths are the same, right? So if the length of cal states is equal to the length of enrollment, right? What does this mean? If their lengths are not equal, if their lengths are not equal, if their lengths are not equal, then there's not like a one-to-one correspondence between the enrollment data and the name of the school. In which case, like it kind of doesn't make sense to put a bar plot because clearly we don't have this like one-to-one correspondence between number of Academy Awards and the name of the movie. So if they're not equal, then we can't really even go on. Otherwise, they are equal. So else they are equal. You may proceed. So a way to make a data frame that associates values like this is that we can make a dictionary. Let's call it D, right? And dictionary gives, and first we say the name of the column. So the name of the column is cal states, and then a list containing the values associated with that column. So essentially, the dictionary, imagine like this is the name of the column and this is the column values. Once again, enrollment, and then enrollment. Let's just see what this looks like. df is equal to, I don't want to call it df. What difference are those? Okay, let's concern that the last are equal converted to a data frame. Okay, so I guess I want us to convert to a data frame there. Anyway, these two should be equal. They are not equal. What? If the length of California states is not equal to the length of enrollment. Are these actually not equal? Yikes. Let's try this out. Print. And 25. Okay. That's yikes. Okay, let's just put in a fake California state school. California. I'm not from California. I don't know. I apologize. All right, California. Right, now they are equal. All right, we just invented a school named California, which has pretty high enrollment numbers. Can't believe I've never heard it before. Okay. So now that they are equal, let's make it into a data frame. So first we take this dictionary, Cal States, enrollment, and then we make a data frame out of it. df is equal to pd.dataframe, and then d. Look at it. Yeah, that looks about right. Yeah. So there's our data frame, and now we work with this data frame to actually plot it. df.plot is equal to, and then we set kind equal to bar. They have told us this here. That was very kind of them. Add an x-axis column. Right. Remind ourselves how to do that. The x-axis is movies, but in this case, it is Cal States. Add the y-axis column. Y is equal to enrollment. The title. What do I want to call it? Schools and enrollment. What is the x-axis? The x-axis is the name of the school. And the y label is, wondering what is that looking at? That's looking at enrollment numbers. Valid syntax, y is equal to enrollment. Oops. And there we go. Okay. Cool. If there are any questions, please reach out. Okay. And now we're going to do something a little, just to show you the extent of how far visualization can go. We're going to be looking at the California housing data set now. We've talked about it earlier. Great. So we want to be looking at a scatter plot this time. And on the x-axis, we want to plot the longitude. And on the y-axis, we want to plot the latitude. Before we see what it looks like, let's imagine what it would actually be. Each value, each row is associated with a house. And the latitude, remember, is like how far up and down it is with relation to like the poles and the equator. And the longitude is how far left and right it is with respect to the... Where is zero latitude? Good question. Anyway, with respect to some point that we've chosen to be zero latitude, zero longitude. Great. So if longitude is plotting left and right, and latitude is plotting up and down of a point, and each of these points is a house, then the longitude and latitude associates the exact position of a house with relation to other positions of other houses. So therefore, if we plot a scatter plot where each point's x value or x position is related to its longitude and each point's y position is related to its latitude, we should kind of get something that looks like the position of each house in California. Probably not scale, but you can imagine that this is sort of what California looks like. And that's what we're trying to get at. So that's pretty cool. Let's see if we can make this a little more. Yeah, so now we're setting it to scatter. X is longitude, y is latitude. We're setting the alpha of each point to 0.3 because you'll see that a lot of points are clustered together. So it'll be easier to see each individual point if it's a little further apart. And the ... just means I'm setting the labels and the axis labels and the title. Okay, and this is where we're getting a little fancy. C is, we're going to be setting another dimension of information. C will vary the color of each point depending on the values of another column, this other column being housing median age. So basically, this point, it's going to be plotted at the point x is equal to -1.2 and y is equal to 37.88. And the color of that point is going to depend on whatever is associated with 41. So 41 is associated with a certain color. 21 is associated with a certain different color. So the point at this location is going to have a different color. So what are the associations between like the number for housing median age and the color of the point? Well, that's given by this CMAP parameter. In CMAP, we have to pass in a color map object. And the way that we do that, we grab that directly from Matplotlib. We say plt.getMap and then the name of whatever color map that we want. In this case, we went with jet. If you go through the Matplotlib documentation, you'll see a bunch of options for CMAPs, which will basically just vary the color depending the color of each point depending on the value of this column. And color bar is equal to true. You'll see what that means in a second. So the takeaway here is that the x value of the point depends on its value in the row's value in the column labeled longitude. The y position of a point is going to depend on the column of the row's value in the column latitude, and the color of the point is going to depend on the value of the row in the column housing median age. So this is what that looks like. The value of the color of each point then is associated with a certain color. So you'll see that the red colors, the warmer colors, are associated with a higher median, I'm saying income, higher median age, right? So you'll see that the warmer colors, so density, they're clustered here, and you'll see like some whatever, wherever. These are going to be where the residents living there are a little bit older. Meanwhile, blue colors, so like really here and here, is pretty well dispersed from what I can tell. Those are the households where the average, where the median age is a little bit lower, right? And still, this x and y gives us where the location of each house is, and this is still like vaguely California type shape. Okay, let's go even one size deeper. All right, we're gonna keep everything. Oh, by the way, color bar. This is the color bar. If you said color bar is equal to false, you won't see this bar. Anyway, now we're using the df.plot again, and we're keeping everything the same, including the color. Now we're adding one more dimension to it. We're going to say that the size of each point is going to depend on the population column of the data frame. And we have to pass in data frame.population because we don't just get to pass in the name of population, the column for free. We need to specify that this will draw like a relation between each row of df to the associated row in df population. Right, and we're dividing it by 100 because they sort of want to like take the size up. Yeah, they want to upscale the size of each point because the units for size are a little bit wonky. So we normalize that by dividing everything by 100. So basically, the idea here is x position depends on the longitude column, y position depends on the latitude column, color of the point depends on the housing median age, and the size of the point depends on the population. Right. Oh, and when I say individual, I meant individual counties. Yeah, the housing median age of certain county. Yeah, each point is a county. Whoops, each point is a county, and these counties, which are the points that are red, are more are older counties in terms of median age, and the blue ones are younger counties in terms of age. Anyway, population. The bigger the point is, means the bigger the population is. The smaller the point is, the smaller the population. So what does that look like? Looks like this, right? You have tiny itty bitty points over here, right? And then this is, guys, I'm not from California. Is this the Bay Area? Is this the Bay Area? I know the Bay Area. Is this Los Angeles? I don't know. One of them is probably San Francisco and one of them is Los Angeles. I'm embarrassing myself. Point is, centers of population, bigger cities, they're going to have bigger points. And that makes sense. These points up here, teeny, teeny, tiny, barely see them. These points clustered by the coast, they're bigger. And still we have that that the older counties with relation to the age of the population are red, and whatever. Yeah, we still have this association between median age and color. So we've drawn associations between position and the actual position, which is why the shape of the graph actually looks like California, which is cool. And we associate the color of the point with the median age of the people living in a county, and we are associating the size of the point with the size of with the population in the county, which is a pretty intuitive way to do it, right? Bigger the point, bigger the county in terms of people. So this is a creative demonstration of what visualization can do with df.plot and Matplotlib and Pandas. Cool. That was a lot. This is a little recap, right? Here's the takeaway. We're using pyplot.plot and df.plot in order to visualize our data frames. We looked at different sorts of graphs that we could be making with that, and we looked at the different styles and customization options that we have for each graph using df.plot and Matplotlib. And then we took what we had and we made a demonstration of it with more advanced tools in df.plot. Whew, that was a lot. So I hope everyone has been able to follow along. Again, I apologize that this is later than usual. Yeah, so if anybody has any questions as you've been watching this, please, I'm going to make a thread in the Slack. Do ask. I will try my best to answer. If I haven't gotten back within like half an hour, just at me. And on Thursday, we're going to be looking at some instances of visualization. It's going to be good. I feel, at least to me, visualization is the area where data science really shows itself to be useful. So, yes. Okay. Right. I'll see you all on Thursday. Take care.